Hello, welcome to this session on the negative binomial distribution. We're going to start off with a review of the binomial distribution. This is when I've got n trials and I'm looking for x successes. Now the probability of x successes from n trials is n choose x. The probability of success to the power of x, the number of successes, times multiplied by the probability of failure, which would be 1 minus p, of course, here it's q, to the power of the number of failures. The number of failures is, of course, the number of trials minus the number of successes. Let's recap that with a nice example. Doris is shooting hoops in his VR basketball game. The probability he makes a basket is 0.3 on any one throw, and each throw is independent. What is the probability that in 10 attempts he makes 6 successful throws? Right, let's have a look. So we know x is going to be binomially distributed. We've got 10 trials, 0.3 probability of success. So let's be more specific here. So the probability of 6 successes is going to be 10. Choose 6. That's the number of ways, remember, that you can have 6 successes and 4 failures. And we need those 6 successes. The probability of those is 0.3 to the power of 6. And then we've got 0.7, the probability of failure to the power 4. So the model works. 10 choose 6, the number of ways, 0.3 to the power 6, the probability of success to the power of how many successes, 0.7 to the power 4, the probability of failure to the power of how many failures. Now that comes to 3 significant figures, 0.0368. Okay, so that's a good recap, I think. Now let's look at the negative binomial distribution. Now, this flips it on its head. We're looking for a certain number, a fixed number of successes. We call the number of successes we are looking for R. So there you go, there's an R must be an integer. And X is the number of times we need to do whatever we're doing, or the number of trials we need to get that number of successes. So obviously X can be R or anything above R. And here's the formula. X minus 1, choose R minus 1, P to the R, 1 minus P to the X minus R. This will make more sense, I think, when we look at it in action. So again, Doris is shooting hoops. The probability is the same, but we're looking at the number of throws he needs to make 6 baskets in this instance. So X is NB, that means negative binomial. We're looking for 6 successes, and we're looking at a probability of 0.3. Okay, so if I apply this, I can say, okay, what's the probability? It takes him 20 throws. I look at this. Well, X minus 1, that's going to be 19. R minus 1 is going to be 5. 19 choose 5. Probability of success, 0.3 to the 6. Probability of failure, 0.7. And there's 14 failures. Okay, and that gives 0.05752, 3 significant figures. Well, let's have a think why that works. We know there's got to be a success on the 20th row because, well, that's when we stop. That's when we get our 6th success. So we're interested in the first 19. We need 5 successes in the first 19. So what's happened is we're saying using a normal or the traditional binomial distribution, 0.3 to the 5, 0.7 to the 14. So for the first 14th rows, we have 5 successes. Sorry, for the first 19th rows, we have 5 successes and 14 failures. Then we have, on the 20th row, a success to make it 6 rows successful on the 20th row. Well, that simplifies, doesn't it? It simplifies to 19 choose 5, 0.3 to the power of 6, add the powers, 0.7 to the power of 14. And that is an introduction to the negative binomial distribution. Thank you very much.